So no one's joined till now, so I'll start within 5 minutes. I'll wait for 5 minutes, maybe participant will join, otherwise I'll record the session. So no one joined till now, so I am going to record the session. You can see later. So I'll upload the content. I'll upload all content on YouTube as well as in the Google folder, so you can access from there. So now I am going to record the session. So let me just is there. So the first question is, okay, so now let us start. The first question is, energy gradient line is, so at a distance of v square by 2z above the hydraulic gradient line. Option B represents sum of kinetic head and the datum head. Option C, the coincide with the water surface in free surface flow. Option D, all of the above. So you have four options. So here the question is about the energy gradient line. So I will go a bit detail. So what is energy gradient line? It is nothing but it's the summation of your the all head, means your P by rho z means the pressure head plus velocity head v square by 2z plus your datum head. So this, when we will add these three terms at several point and we will join the all point with a single line known as your energy gradient line, EGL. One term associated with this energy gradient line, your the hydraulic gradient line. So in hydraulic gradient line we'll only take these two things, P by rho z plus z, not v square by 2z, but in the energy gradient line we need to take the v square by 2z. Now at a distance of above hydraulic gradient line, yes, definitely. So the first one is correct. Represents sum of kinetic head and datum head. Represents sum of kinetic head and the datum head. So this is your kinetic head and this is your datum head. Coincide with the water surface in free surface flow. So second one I think not correct. Why? Because it's sum of pressure head, kinetic head and the datum head. So in the question only kinetic head and the datum head is given. So this is wrong. Third one, coincide with the surface, water surface in the free stream flow. Not. It is above the your free surface. How? Let me just, no, you cannot say directly whether it is coincide with the surface and all. When you are going to consider the open channel flow, then you can the write the statement like that. But here it is not written very clearly whether you are talking about, whether option is talking about the pipe flow or the open channel flow. So that's why this option is have some need some modification actually. Okay, anyway, so I'll explain you what is coincide with the surface flow. So this is not correct. So your option A is correct for this question. So I'll discuss little bit more about it. This is very important concept in the fluid mechanics. So this is, let us suppose this is a pipe and one channel I'll also draw here. This is your channel. So the channel I'll draw here. So channel with the slope of S, and this is pressurized flow, remember please. Let us insert the piezometer. Once you will insert the piezometer, you will see the rise of water level in the piezometer. Insert here also. Insert here also. So due to friction of the pipe surface, some energy will be lost. So water level will be decrease. Here all water level also will be decrease. And you join this line, it is known as your hydraulic gradient line. This is your hydraulic gradient line, HGL. Now go above V square by 2Z. Here V square by 2Z. Here V square by 2Z. So you need to write the local V square. So not the all V, maybe the all V same or not same, it depend on the condition of the pipe and all. So if you will join this line, it is your energy gradient line. So this is simple, very simple one. In case of open channel flow, what will happen? Let us suppose this is a free surface or water surface profile, you can say. This is the free surface and water flowing from this side to this side. Now, so here your datum head, I think anyone joined? Yeah, one student is joined already. So let me just, hello Ashok, I am audible, please just confirm. I am audible to you? Okay. So let me just write here. You can write in the chat box if you are not able to speak. Your microphone is not working, you can write. Okay, thank you. Thank you, Ashok. So, hope you understand the first question. If yes, you can write in the chat box yes, or I don't know when you have joined. So, because no one was joined, so I have started the session. As we have joined, so that is good thing. Okay. Okay, thank you. So now let us move on the next one. So here it is open channel flow. In open channel flow, what, let us, your the energy gradient line may be coincide with this energy gradient line with the water surface profile, because the pressure head is that much, and if you are going to consider your datum is the bed level, so you can say very clearly your energy gradient line, your the hydraulic gradient line, not energy gradient line, will coincide with the your free surface. But above the V square by 2Z, above this line V square by 2Z will be your the energy gradient line. So if you are going to consider open channel flow, then also their option B is wrong. So only option A is correct here. So now let us move on the second one, second question. So here explanation is also given, as we can see here. The hydraulic gradient line represents the sum of pressure head and the elevation head. Elevation head, the energy gradient line, here is the HCl, and the energy gradient line on the other hand include the kinetic energy head in addition to pressure head and elevation head. Therefore, energy gradient line is indeed at the distance of v square by 2z above the HCl, as difference between two line is the velocity head. So this point you need to remember. These are a very standard question, so you need to remember always. Okay, so now let us move on the next one, next question. So the next question is, okay, Tanya is also joined. So next question is very interesting question from your exam point of view. So here, question number 2, which of the following statement is are true with respect to the kinetic energy correction factor? So most flow encountered in practice are turbulent for which alpha is close to 1 and hence alpha is ignored. Next, option B, kinetic energy term are often small relative to other term in energy equation and hence alpha is ignored. Next one, in laminar flow, alpha is significant and it is necessary to include alpha while analyzing the fluid flow problem. Option D, all of the above. So you have four options. Read very carefully the question. This question is very important and just try to write your answer in the chat box please. So everyone please just write your answer in the chat box. Okay, so Alok is telling D option as you have replied. Okay, so other participant also just try to write your answer in the chat box. So I'll wait 1 minute, after that I'll explain the question. So I'm waiting for other participant. Maybe just read the question and try to recall your concept from your NPTEL course and try to write your answer in the chat box. Okay, so Tane is also telling the D option D is correct. So let me just read. Okay, let me just show you the answer. Yes, D is correct here. So remember always please, what is the main thing here? Let me just explain you. The what is your actually the kinetic energy correction factor, why it is required? As you know, in laminar flow, because for the calculation purpose, let us assume the Bernoulli equation. What is Bernoulli equation? P by rho z plus I think some student disturbing. Oh man, I think mute the participant. Yes, now it is okay. So now let us consider Bernoulli equation P by rho z v square. This v is the average v. Remember please. V square by 2z plus z is equal to your total head, or you can say the constant if you are going to take at 2 point. Okay, so now this average velocity. So as you know, in the laminar flow your velocity profile is like that, parabolic. In turbulent flow, this is for laminar. In turbulent flow, your velocity profile is like that, slightly linear, then it is parabolic. And what is average velocity? Average velocity means throughout the constant velocity, throughout the depth of the water. If this is depth, this is your depth of the water flow and this is your velocity. Means your parabolic part, okay, your parabolic part is, you need to modify the parabolic part. Here is velocity 0, but when you are going to average the things, okay, so now let us, someone disturbing, okay, no issue. So here the important thing, you are going to average the things. When you are going to average the things at the place of zero velocity, you are going to provide here the average velocity. At this low velocity, here also you are going to write the average velocity. When you will average this graph, so you need some correction, because your graph is like that, you are everywhere you are going to give the constant value. Averaging means what? You are providing the constant value throughout the depth of the flow. But in turbulent flow, if you will see, more or less throughout the depth the velocity is constant. So that's why here it is written, most of the encountered in the practice are turbulent. In practice, the turbulent flow mainly, for which alpha is close to 1. When you will go for the derivation for kinetic energy correction factor, we will get close to 1, maybe 1.05, 1.01, like that. So you can ignore, no issue. Kinetic energy term are often small relative to other term in energy equation, hence alpha is ignored. Okay, nice. So next, in laminar flow, alpha is significant. Why is significant? Because parabolic here the distribution, and it is necessary to include alpha while analyzing the fluid flow problem, and all of the above. So definitely all three is correct. So D automatically will be correct one. So yes, D option is correct. So you all correct. Now I'll just read the solution. So kinetic energy correction factor account for difference between the actual kinetic energy of a fluid flow and the kinetic energy calculated using the average velocity. Your kinetic energy correction factor is nothing but it is the ratio of your actual one, your actual kinetic energy divided by your average kinetic energy. So this will give you the kinetic energy correction factor. So now let us remember, this question is very important for the competitive exam point of view also. So next question, numerical. Question 3. Water flow in a 10 centimeter diameter of a pipe at a velocity of 0.9 meter per second. The mass flow rate kg per minute of, remember you need to calculate in kg per minute, of water in a pipe is. So option A 353.4, option B 329.9, option C 421.23, option D 424.11. So here you need to calculate what the mass flow rate in kg per minute. So you have to be very careful during calculation. Remember the kg per minute. So I'll give you the 2 minutes. So within 2 minutes, please just try to write your answer in the chat box. 2-3 minutes you can take. After that, I'll explain the detailed solution. So I'm waiting to all of you. So please just try to calculate and try to write your answer in the chat box. Okay, so Tana is telling D option is correct. Okay, I'll wait 1 minute more for other participant. Okay, so let me just explain. So here you need to calculate the mass flow rate, means the change in mass or mass per unit time, you can say. So what is mass? Mass is nothing but, or rho is density is m by v. So mass is rho into volume. This is volume, remember please. Now if you are going to divide with t, m dot means mass per unit time, means what is rho, this you can write like that, rho a area into length. So rho a or L by T, what will be the L by T is V, rho AV. So mass flow rate is nothing but rho AV. So this is your formula for mass flow rate. Now, so yes, option D is correct, but how it is correct? This is the, here how we will calculate. So now the density water flow is given. So water flow means density is already you know very well. So well known density 1000 kg per meter cube. Area is given 10 centimeter diameter of the pipe. So pi by 4 into 0.1. Why? Because I am going to calculate in meter. So 10 centimeter is nothing but 0.1 meter. So this is the square, and velocity is given 0.9 meter per second. So I am going to convert this velocity in meter per minute. So 0.9 meter per second, if you are going to convert this second into minute, so 1 minute is equal to 60 second, and 1 second is equal to 1 by 60 minute. So 1 second, here is 1 second. So for 1 second, if you are going to write in minute, so you need to multiply by 1 by 60, not 16. So this will be your 0.9 into 60 meter per minute. Now you need to put everything here. So rho is 1000, pi by 4 into 0.1 square into 0.9 into 60. So after the calculation, after these all calculation, you will get 7.068 into 60, and when you will multiply with the 60, you will get finally 4 to 4.11 kg per minute. So hope you understand the things. So if you somehow if you forget the formula of the mass flow rate, so remember one thing, mass flow rate is nothing but mass, rate means time, mass per unit time, or your unit is also given. So kg per minute, so kg per minute, mass by mass per unit time, mass. And what is your mass? It is nothing but is rho into volume. So you can think like that, and definitely you will get the answer. Now let us move on the next question, question number 4. Very easy question but important. Bernoulli's equation is an equation of conservation of mass, conservation of momentum, conservation of energy, conservation of angular momentum. So just think very carefully and try to write your answer in the chat box. Question number 4. Okay, so Tanya is telling C option is correct. So conservation of energy, yes, definitely this is a well-known question. So I'll not take much time here. So definitely your Bernoulli equation is an equation of conservation of energy. So very simple. Now one thing I'll suggest here, that you have to remember the assumption behind the Bernoulli's equation. So if you will remember these assumptions, this will be very helpful for you for solving the question. Definitely you will get the question from here in your final exam. So remember always, you have to recall all the your all assumption behind the Bernoulli equation. That is very important. So what is written actually here in the solution part? Bernoulli equation is an equation of energy conservation of fluid flow. It states that for an incompressible, frictionless fluid, the total mechanical energy, sum of pressure energy, kinetic energy, potential energy along a streamline is constant. Remember please, along a streamline. Okay, so now let us move on to the next question. Question number 5. Again, very simple question, but you have to remember. In a venturimeter, which measures the flow rate of fluid in a pipe, the pressure difference between the wide and narrow section is due to difference in elevation, difference in fluid velocities, difference in temperature, difference in fluid densities. So you can just understand, you can just read very carefully the question and try to write your answer in the chat box. Okay, so you are telling the B option is correct. Tanya is telling B option is correct for question number 5. Okay. Okay, Ashok is also telling the B option is correct for question number 5. Okay. So B is the difference of fluid velocity. So in venturimeter, which measures the flow rate of fluid in a pipe, the pressure difference between the wide and narrow section is due to difference in fluid velocity, you are telling. Okay. Yes, option B is correct. Let me just read the solution part, detailed solution part. A venturimeter operates based on the Bernoulli principle, which relates the pressure difference between 2 points in a streamline flow to the difference in their velocities as the fluid flow through a constraints. Its velocity increase leading to a decrease in pressure. The pressure difference thus arises due to difference in velocity between the wider and the narrow section of the meter. Same thing it written here. So now let us move on the next question. Question number 6. In a steady flow system, the momentum flux correction factor beta is used to account for variation in pressure across the cross section, non-uniform velocity distribution, change in density of the fluid, and the presence of shock wave in a fluid. So you have 4 options. The momentum flux correction factor. So you have 2 type of correction factor. One is kinetic correction factor and another is your momentum flux correction factor. So just please try to understand the question and try to write your answer in the chat box. Okay, so Tanya is telling B option is correct. Okay. Means non-uniform velocity distribution you are talking. The momentum flux correction factor. Okay. Other participant, please just try to write your answer in the chat box. I'll give you 1 minute more. So just think very carefully the question and read the option also very carefully. Okay, so let me just show you the answer. So here option B is correct. Non-uniform velocity distribution. So momentum flux correction factor beta is introduced to account for the non-uniform velocity distribution across a cross-section of the flow. In real life scenario, the velocity distribution is not uniform, especially in the turbulent flow. The momentum flux correction factor adjusts the momentum equation to account for these variations, ensuring accurate calculation of the momentum transfer. So remember please. So this correction factor is account your momentum correction, because you are averaging the things. If you are going to averaging the things, you need to apply some correction. Now the question number 7, which of the following assumption is not part of Bernoulli equation? So here the question from assumption. So flow is steady, flow is incompressible, flow are no energy flow are no energy losses due to friction, the fluid density varies along the streamline. So you have 4 options. So just try to write your answer. Okay, so Ashok is telling D option is correct. Okay, I am waiting for other response. So read very carefully the question number 7. Okay, so Tanya is also telling D option is correct. So definitely you both correct here. So the fluid density varies along a streamline. This is not the part of your Bernoulli equation assumption, your Bernoulli principle assumption. So let me just read detailed solution for you. So Bernoulli equation is derived under the assumption of steady incompressible flow with no friction loss and along a streamline. If the fluid density varies along a streamline, the fluid is not incompressible. The which violates one of the basic assumptions of the Bernoulli equation. Therefore, option D is correct. Okay, means the option D is correct because this is not your assumption of the Bernoulli equation. Let me just go for the next question. Question number 8. Here you have the 5 options. Bernoulli equation used in pipe flow. Each term represent energy per unit mass, energy per unit volume, energy per unit weight. All of the above means all 3 A, B, C, and D none of the above. So first read carefully. Okay, so Ashok is telling C option is correct. Energy per unit weight. Okay. Waiting for other response. Okay, so Tanya is telling D means all 3 is correct. A, B, C. Energy per unit mass, energy per unit volume, and energy per unit weight. Okay, so let me just, yes, option C is correct, energy per unit weight. So let me just explain you. So you know the Bernoulli equation is P by rho z plus V square by 2z plus Z is equal to the your energy, or you can say the, I'll write the total head H. So P is your force, that is Newton per meter square, divided by kg per meter cube into meter per second square. And what is Newton, I want to write. So this is your kg into meter per second square. So meter per second square is cancel out. Kg will be cancel out. Meter cube square will be cancel out. So only 1 meter is there. So similarly, you have the meter unit for Z also. You have meter unit for this also. Meter per second square. Meter per second, because it is velocity. Meter per second whole square divided by meter per second square. So now meter square by second square divided by meter per second square. So only you will remain with meter. So all 3 terms have the meter. Now you can energy per unit weight. Energy per unit weight means what? Energy per unit volume means what? And energy per unit mass means what? Means what is energy unit? Energy unit is nothing but you know already, the Newton meter per unit mass kg. Next one, Newton meter per unit meter cube, that is volume. Newton meter per unit weight means Newton. So Newton will be cancel out. You will remain with what? Meter. Here, so meter remain with meter and it is matching with this. So you can write these term in terms of, you can say very clearly the energy per unit weight, but energy per unit mass you cannot say, energy per unit volume you cannot say, as you can see here. So always remember, please, these are just game of the unit, nothing, but you have to give answer very precisely, very carefully. Now let us move on the next question, question number 9. Okay, so here bit explanation is given, so I'll read. So Bernoulli's equation is the integration of Euler equation which is represented by following equation: P by rho z v square by 2z plus z is equal to constant, and each term of above equation represent energy per unit weight, or you can say the meter, the unit of meter length, you can say. Now the next question is numerical. The pressure head and kinetic head of water flowing through a pipe of diameter 60 centimeter are 50 meter and 4 meter respectively. Determine the piezometric head of the water at a cross section which is 5 meter above the datum line. So option A 59, option B 60, option C 54, option D 55. So just read very carefully the question and try to think what question is asking, how I will approach the question. So this is the main aim of this the NPTEL PMRF TA. So you have to think very carefully how to approach the question and how to solve the question. Okay, so now I am waiting for your answer. So you can take very 5 minutes, you can take, solve very, just first think what question is asking. Okay, so let me explain you the question. Okay, so he's typing, so he is telling option D is correct. Tanya is telling option C is correct. Okay, so okay, so let me just explain you. The pressure head and kinetic head of water flowing through a pipe diameter of 60 centimeter are 50 meter and 4 meter. Means pressure head is 50 meter and kinetic head is 4 meter. Okay. Determine the piezometric head of the piezometric head. Remember please. Piezometric head, here you need to calculate, of the water at a cross section which is 5 meter above the datum. Means your z value is given 5. Means P by rho z is given 50, V square by 2z is given 4 and z is given 5. What is piezometric head? Whether it is combination of all three, whether it is combination of these two, whether it is combination of these two, whether it is combination of these two. So you have to think very carefully actually. So in the first question I have told you, I think, let me just show you here. Okay. So here I have actually not written, but I have already told you P by rho z plus z. That will include your hydraulic gradient line, or you can say this is your, or you can say when I was drawing this figure, so I was telling this is your piezometric head, this is your head. Above the piezometric head you need to add the V square by 2z, then after you need to join the line, you will get the energy gradient line. So your piezometric head is nothing but it is the addition of these two, your pressure head. Let me just show you what was the question. Question number 9 I think. Yes. So it is your nothing but the piezometric head is your P by rho z plus your datum head. So P by rho z is 50 plus datum head is your 5. So finally you will get 55. This will be your correct answer. So 55 is the correct answer. Remember always please. If question was asking the total head is nothing but summation of all. So that will be your 59. Remember. Now this is your, the here explanation is very well. The P by rho z is pressure head, then you have velocity head, then you have the datum head, and total head is pressure head, velocity head, datum head, and piezometric head is pressure head and datum head. One thing you can write very carefully from here, total head is nothing but your piezometric head plus your velocity head. So this thing you can also remember for always, so you will not confuse. Now the next question is question number 10. So which of the following equation is based on the fact that the mass flow rate at any section remain constant? So first, Bernoulli equation, second, continuity equation, third, momentum equation, fourth, steady flow energy equation. So please just think very carefully. The question number 10 and try to write your answer in the chat box. Okay, so you both are telling option. Okay, Ashok is telling option C, and Tanya is telling option B is correct. Continued equation. So which of the following equation is based on the fact of based on the fact that the mass flow rate at any section remain constant? Here question is about the mass flow rate. Remember please. So mass flow rate is your based on the continuity equation. Remember that is conservation of. So Ashok is telling momentum equation, not this is your continuity equation, conservation of mass. Okay, so the continuity equation is a fundamental principle of fluid mechanics that state that the mass flow rate of a fluid remain constant from one cross section of a pipe to another and provide the flow is steady and incompressible. So very interesting one. So now I'll take 5 minute break. You can also take. So I'm going for water. So you can also go. So here question number 11. Just see and try to solve. Or you can also take 5 minute break. So we'll meet again after 5 minutes.
मेरे को घर की गाड़ी दिखे मुझे याद है ना क्या ही करूँ घर जाके मैं वापस चली आई
Okay, so now let us start question number 11. So question number 11 is a large tank open to the atmosphere is filled with water to a height of 8 meter from the outlet tap. A tap near the bottom of the tank is now open and water flow out from the smooth and round outlet. Determine the maximum water velocity at outlet meter per second. So option A 13.25, option B 11.72, option C 12.53, option D 10.55. So you have four options. So just try to understand. Okay, so Tanya is telling C option. Okay, already calculated. So I'll give another 5 minutes for other participant. So because now I have started the. Okay, so Ashok is telling B. Okay, so let me just solve. So the question is, large tank means you can assume like that, and open to atmosphere means the free, no close at the top, no cover, and the water height of 8 meter from outlet tap. So here 8 meter you have filled already, so this height is 8 meter. Okay, a tap near the bottom of the tank is now open. So here you have one tap. Here you have one tap in the bottom and water flow out from the smooth and round outlet. Means the question is try to explain smooth and round outlet means there is no loss, the friction loss. Determine the maximum water velocity at outlet meter per second. So you need to calculate the velocity here at this point. This is 2 and this is 1. So you need to calculate the velocity. If I consider here it is 2, so you need to calculate the V2. So for that you need to apply the Bernoulli equation. So 1 you can apply here, that is 0.1. Another you can apply here, 0.2, and both are open, means at both location your pressure is what? P atmospheric. So if you will write, because as per the Bernoulli, what your pressure, that is the energy at 2 point will be the constant total energy. So P by rho z plus V square by 2z plus Z is equal to P by rho z plus V square by 2z plus Z. So this is 1, this is 1 V, not, this is 2 actually, this is 2 and this is 2 and this will be 1 1 1 everyone. So your density is constant, so anyway this term will be the constant both side. So the both side if constant, so when you will, that will be cancel out actually. Now what is V1? In the large tank V1 will be the 0. And what is Z1? Z1 is nothing but, if you are taking the datum here, so Z1 is 8. So this is 8. Now what is V2? You need to calculate, this is question mark. And what is Z2? Z2 is 0 because you are taking the datum at the Z, at your location 2, at the level of 2. So now finally you remain with what? V2 square by 2z equal to 8. So very easily now you can calculate. So V is equal to root 2Z8, which is, this will be your, if I take the Z is equal to 10, this is 20 into 8, 16, 160, V is equal to 160. So let me just see, the option C will be correct here. Yes, option C should be correct. Yeah. So 12.53 will be the correct answer. So hope you understand how we will calculate the things. So such type of question you can think, or you can expect in your final exam, some competitive exam, gate exam also you can expect such type of questions. But uh, once we have the experience, there is this is not a difficult question, but yes, in the first, if you are going to solve the first time, then it will be slightly difficult. Okay, so Ashok is writing something, so please just tell me what you want to say. I'll wait. So you are telling control volume, control volume. Okay, you can consider the control volume, no issue. You can consider. Even if you will consider the control volume, the same, you will get the same answer. Okay, coefficient of velocity you are telling. Okay, so because in the question there is no clue for the coefficient of velocity. If you will see here, because one thing is you have to very clear for objective question. So because this is not a conventional question, so you cannot go like, you should consider your the, like, this is not kind of the mains exam or university exam. So this is the objective type of question. So one thing is very clear. So in objective question, so whatever the data is given, you have to look that thing only, unless the question is not, actually in objective question what, how we design the objective question. If we are trying to, if we will say the, we are going to consider the coefficient of velocity, then you are solving with different coefficient of velocity, someone will solve the different coefficient of velocity, how will the match the answer? So in such type of question, means the objective question, generally if the question will ask to add the coefficient of velocity, then the value will be given. Here value is not given, so no need to consider the coefficient of velocity here. So hope you understand the things. The, this is the actually way of solving the objective question. So always remember, please. Okay, so now let us move on the next one. Question number 12. Question number 12. A horizontal water jet of velocity 20 meter per second and cross-sectional area 0.01 meter square strike a vertical flat plate and is turned to flow parallel to the plate. If the density of water is 1000 kg per meter cube, calculate the force exerted by the jet on the plate. So option A 40 Newton, option B 4000 Newton, option C 400 Newton, option D 40,000 Newton. So you have the option, but it's a multiplication of 4, or you can say the 40. So 10 times, actually 100 times or 1000 times. So just think and try to solve very carefully. So I'll give you 5 minutes for this question. A bit long question, so that's why you will get the more time. So Alok is telling, Ashok is telling actually B option. Okay, that is 4000 Newton. I am waiting for other response also. Okay, so Tanya is telling C option 400. Okay, so let me just solve the question. Horizontal jet of water with velocity 20 meter per second. So horizontal jet of water. So now this is jet of water, horizontal. Okay, so the velocity here is 20 meter per second and the cross sectional area is given. This area, cross sectional area, is 0.01 meter square. Strike on a vertical plate and is turn flow parallel to the plate. Means here is the vertical plate is here. Stationary, I think vertical plate it should be, because the velocity of the plate is not given, means it is a stationary. You have to consider like that. So it is striking and going like that. Okay. Now, if the density of water is 1000 kg per meter cube, okay, the calculate the force exerted by the jet on the plate. So what will be the force? Force is nothing but your mass into acceleration, but here you need to write in the terms of mass per unit rate into velocity. So this will be your force. And what is force? What is m naught? M dot what is? Rho a v, another v is given, so rho a v square. Now what is rho? This will be 1000. A is your already given in the question, 0 1. And what is v? V is your 20, so v square. Now you can write here, I'll solve here. So 1000, this is 0.01 into 1 by 100, means once you will remove this point, 20 will be in denominator part, and this will be your 400. So 20 and 20 will be cancel out, so finally you will come up with Newton, 4000 Newton. So your option C should be 4000. So option B will be correct here. Your final answer is 4000. So option B will be correct here. Remember please. So okay. So here is the calculation is given. So I'll not go, because same thing I have explained here. Okay. So next question number 13. Question number 13 is, a pipe carrying water has a reduction in diameter from 0.3 meter to 1.15 meter. If the velocity of water in the larger section is 2 meter per second, determine the velocity in the smaller section using Bernoulli equation and the principle of continuity. So you have four options: 8 meter per second, 6 meter per second, 4 meter per second, and option D 2 meter per second. So please just try to calculate the answer for this question within 5 minutes. So I'll give you 5 minutes. Okay, Ashok is telling option A is correct. Okay, I'll wait 2-3 minutes all more, no issue. You solve very carefully. The question is very very important. I'll wait another 1 minute, please. Okay, so now I am going to solve. So here you have a pipe carrying water has a reduction in diameter from 0.3 meter to 0.15 meter, means you have the tapered pipe. If the velocity of water in the larger section is 2 meter per second, determine the velocity in a smaller section using Bernoulli equation and the principle of continuity. So here one thing is very very important. Because here is no data for your the elevation, means whether it is inclined pipe and whether it is the horizontal pipe. So if data is not given, you can go with the horizontal pipe. So this question is insufficient. Here need to write very carefully a horizontal pipe water has carrying water has a reduction in diameter 0.3, like that. This is your 0.3 meter, this is your 0.15 meter. If the velocity of water in the larger section 2 meter per second, I'll consider V. This is your section 1. This is your section 2. 2 meter per second. Okay. Determine the velocity at a smaller sections. So here we need to calculate. So V2 I'll write here. This is diameter is given, so D2. This is your D1. This is your V1. Now determine the velocity in the smaller section using Bernoulli equation and the principle of continuity. So one thing also you can apply, A1 V1 is equal to A2 V2. You can apply very carefully, no issue. But why the question is telling you apply the Bernoulli equation and the continuity equation? So Bernoulli equation is different, which is P by rho z plus V1 square by 2z Z1 is equal to P by rho z plus V2 is, because both open in the atmosphere, it is also not given whether it is open in the atmosphere and where it is open. So again it is very difficult. V square by 2z plus Z2. So the for applying the Bernoulli equation, the many information is insufficient. So I think we have to go with the continuity equation. So let us see how. Yes, here continuity equation is very very applicable, because I don't know why in the question is written using Bernoulli equation, and it should be, or maybe for confusing the student, but okay, no issue. So here A1 B1 you can apply. So A1 is what? So anyway, option A is correct, 8 meter per second. But how? Pi by 4 into D square 0.3 V1 2 meter is equal to pi by 4 into 0.15 square into V2 you need to calculate. So pi by 4 will be cancel out. So you will remain with what? V2 is equal to 0.3 into 0.3 into 2 divided by 0.15 into 0.15, or you can write 3030 here. So this will be cancel out. So 2 times 2 times. So 2 to the 4 to the 8 meter per second. So V2 is equal to 8 meter per second. So very simple, but the question was bit confusing. So remember. Okay, in that case here it is no need to add the horizontal. The question is correct, but bit confusing when it is written. When it is written here, the section using you need to calculate the velocity at the smaller section using Bernoulli equation and the principle of continuity. Slightly confusing, but anyway, now let us move on the next question. question number 14. An inviscid fluid with a density of 1000 kg per meter cube flow steadily through a horizontal pipe with a change in diameter. At a certain section, the diameter is 0.1 meter and pressure is 200 kg pascal or kilopascal, 200 kilopascal. If the velocity at this section is 2 meter per second, what is the pressure at another section where the diameter is 0.2 meter? Again 2 marks question. So option A, 198.7 kilopascal, 196.5 pascal, 199.0 kilopascal. Option D, 201.8 kilopascal, all unit in the kilopascal. So you can see very close, so you have to very careful, the all option very close to around 200. So you have to very careful during the calculation, the calculation should be very clear. Okay, so now I'll give you another 5 minutes for this question, so you can take your time and try to solve the question correctly. Okay, so Tanya is telling option B is correct for question number 14. Anyway, I'll wait for another 2 3 minutes for other participant. Okay, so Ashok is telling option D is correct. Okay, so let me just solve. An inviscid fluid with a density of 1000 kg per meter cube. Okay, so you have density 1000 kg per meter cube, flow steadily through a horizontal pipe. Okay, pipe is horizontal, steadily flow. Okay, nice, with a change in diameter. So pipe is not like that. Pipe is bit tapered, change in diameter. This is horizontal. Remember please. Okay, at a certain section the diameter is 0.1 meter and the pressure 200 kilopascal. Okay, so let us suppose here it is your at this location, this is your certain section, and here is the diameter of the pipe is d1 is 0.1 meter and pressure is given 200 kilopascal. Okay, if the velocity at this section is 2 meter per second, velocity is also given 2 meter per second, what is the pressure at another section? So here it is the section 2. This is not in atmosphere, you cannot say directly this is atmospheric pressure. We are taking this section within the inside the means the some upstream of the outlet, remember. So here this is your point 2, this is point 1, so you need to calculate pressure at 2, another where the diameter is 0.2. Okay, so the figure should be reverse, or you can, okay, let me draw here very carefully. So sorry, the figure should be like that, the similar figure, but the here is diameter is 0.2 at this location, this section, this is 2 section and this is section 1. So at section 2 your diameter d2 is 2, this diameter here to here, this diameter is given 0.2 meter. Okay, and here you need to calculate pressure at 1, diameter is given 0.1, so d1 is given 0.1, velocity is given 2 meter per second v1, and your pressure is given p1 is 200 kilopascal. So this is the question. Okay, everything is fine. So now you can up here, because question is asking about the pressure, you cannot apply simply your the continuity equation. So now we need to apply this Bernoulli equation. So P1 by rho z is data you have already. V1 by V1 is square by 2z, you data also have. Z, whether Z will be, if I am taking the datum is the center line, so definitely your Z will be the 0 here, is equal to P2 you need to calculate, V2 is not given, so V2 also you need to calculate, Z2 will be the 0. And how we will calculate the V2? So V2 calculation, now your continuity continuity equation come in the picture. A1 V1 is equal to A2 V2. You know very well. So V2 is equal to what? A1, so pi by 4 into 0.1 square. A1 V1 is nothing but is 2 meter per second divided by A2 pi by 4 into 0.2 square. So pi by 4 will be cancelled out. 0.1 into 0.1 into 2 divided by 0.2 into 0.2. So this will be cancelled out. So 2 by 4. 2 by 4 means what? 0.5 meter per second. So velocity here is 0.5 meter per second. One thing you can remember, you can interpret it. Area is increasing, velocity is decreasing. As you can see here, area means diameter. You can directly say here the diameter. So diameter of circular pipe, we are talking about circular pipe. Diameter of pipe increasing, velocity is decreasing. As you can see here, diameter from 0.1 to 0.2 means 2 times. Diameter increasing 2 times, and velocity is decreasing how much times? Velocity from 2 meter per second to it is come 0.5 meter per second. So means it is reducing 4 times. When you will multiply 0.5 with 4, then you will get 2, means the velocity reducing is 4 times. Now if the velocity is reducing, and as per the Bernoulli, you know very well, the energy at section 1 is equal to energy at section 2 if this term at section 2, if this velocity is decreasing, means this value is decreasing. So when this value will be increased, then you will equate the things, means pressure at section 2 means the larger diameter will be increased. Let us see for the calculation, using calculation. So P1 is given 200 kilopascal, rho z, which is 1000. I'll take 10 for the calculation purpose. Okay, now V1 is given 2, plus 2 square divided by 2z, 2 into 10 is equal to P2 need to calculate rho z plus V2 we have 0.5 square divided by 2z. So now for here what you will get 2, and answer we need in the kilopascal, so I'll keep the same, all the your parameter in the same, because here it is P1 is given kilopascal, and we'll get the P2 also in kilopascal, so no need to change here. So this will be your, this will give you 0.02 plus this is 4, so 0.2 is equal to, because 2 into 2 square means what? 2 into 2, 1 to 2 will be cancelled out, so 2 by 10 is nothing but 0.2. Now P by 1000 or 10 raised to 4 I'll write here, plus 0.5 into 0.5 divided by 2 into 10. So here, so when we will remove this point, another 20 will come here. So let me just, and here 25, 5 into 5 it is 25. When we will divide this the 100, this will be go in 4 times, means 1 by 80. So plus 1 by 80 you have, this is 1 by 80. Now 0.02 plus 0.2 minus 1 by 80, okay, is equal to, or here, into 10 raised to 4 is equal to P2. So this will be your 0.02, 0.2 means 0.22 minus 1 by 80, and 1 by 80 will be how much? 1 by 80 will be how much? When you will divide with 1 by 80, it will become around 0.01. I'll write 0.01, no issue for the calculation purpose. So 0.21, 0.21 into 10 raised to 4. So it is around 210. So something is like that, maybe the calculation here. So it is going near about, it is maybe option D. Let me just see. Yes, option D is correct, because we have taken the 10 at the place of 9, so that is also make change. So hope you understand the concept, how we will approach such type of question. So it is like that, option D is correct here. So you can calculate very easily using calculator. So the same thing, you need to apply the first your continuity equation, then after getting the velocity you need to apply energy equation, that is Bernoulli equation. So hope you understand. This is the last question for today class. So the question is, the following sentences are related to Bernoulli equation, find out the correct option. Bernoulli equation is applicable to ideal incompressible fluid. The flow must be irrotational. The gravity force, pressure force and viscous force are considered in Bernoulli equation. Option 4, the rotational flow. The Bernoulli equation can still be applied, but only along the same streamline. So you have 4 options. Please just try to understand and try to write your answer. Which options is here? I think you have the multiple choice question. Maybe 1, 2, 3 is correct. So I think the option should be, oh, you have the another also, 5 also you have, 6 also you have, okay. So now, so 5 is, the heat transfer into or out of the fluid should be 0 to apply Bernoulli equation. 6, the 6 point, the Bernoulli equation can be applied for both steady and unsteady flow. So you have 4 options. So please just read the question very carefully, try to understand and try to write your answer in the chat box. Okay, so Tanya is telling D option, 1, 2, 4, 5, okay. Ashok is also typing, so let me just see that. his answer, then I'll discuss. Okay, so you both are telling option D. Okay. So D option means 1, 2, 4 and 5. Why not 3 and 6? So the gravity force, pressure force and viscous force are considered in Bernoulli equation? No. Only gravity force and pressure force. For in the derivation of your Bernoulli equation, what we do, it is nothing but force is equal to rate of change of momentum, mv by t, rate of change of momentum. So in Bernoulli equation, what we take? We take the gravity force, I'll write here the Fg, plus your pressure force, the summation of force here. So I'll not go in the right hand side part. So this is, so here no viscous term, but the this actually the not considering the viscous force, this is overcome by the Navier-Stokes equation. In Navier-Stokes equation, you will consider all three things: Fg plus force of pressure plus force of viscous, not P, this is force of viscous, is equal to rate of change of momentum y with respect to time. Okay, so rate of change of momentum. Okay, so all three things in the Navier-Stokes equation, but in Bernoulli equation only two. So that's why this is the main reason behind, if you have, if you are going to solve the, this is your boundary layer concept, if you are going to apply the Navier-Stokes equation or Bernoulli equation, both you want to apply here. So here, because viscous effect is dominating within the boundary layer, so here you cannot apply the Bernoulli equation, here you can apply the Navier-Stokes equation. After that, because you can see the velocity profile is like that, up to that your viscous dominated, after that the velocity profile is like that, no viscous effect. So here you can apply the Bernoulli equation. So outer part of the boundary layer you can apply the Bernoulli equation, and within you cannot apply, you have to go with the Navier-Stokes equation concept. So this is the another concept I want to tell you. So okay, anyway, so the question, or you are telling not 6, the Bernoulli equation can be applied for both steady and unsteady flow. Okay, so you are telling this option 3 and 6 is not, and all is correct. Yes, all are correct. So the why it is not? Because this is the first assumption for the Bernoulli equation. The flow should be steady, should be ideal, irrotational, inviscid. Flow is along a streamline. Flow must be incompressible. These are the assumptions. So always remember, please. So hope you understand the things. Okay, so one thing is important here, and even if the flow is irrotational, we can still apply Bernoulli equation, but only along the streamline. One thing is important here, please. If you have flow, maybe all things is satisfied, but two thing is, uh, one is rotational and another is irrotational. Means if you have rotational flow, you can apply Bernoulli equation along a streamline only. You can apply, no issue. But if the irrotational, you can apply anywhere in the flow domain, here to here. No need to think about much the streamline, you can apply anywhere. But if you have this the rotational flow, you have to go with the streamline only. So this is another concept. So okay, so now for today, thank you from my side. So we'll meet again on the next class, maybe on, yes, on 25, next Tuesday. So thank you all for joining. Okay, thank you. So okay, thank you all. Now you can just leave the class. Then also you can leave the class, please. Thank you. Thank you, Danya.